com. So today we are going to learn tree data structure, right? So let's understand what is tree data structure, and let me first explain what is tree data structure. Okay, so we know we may know or may not know, right? Some of you are a very beginner, and some of are have some idea about the tree, right? So I'm going to explain you what is tree and how we will implement the insertion, deletion, and how we'll find the tree is binary tree or not, right? So these things we will cover in this lecture. In the last lecture we have learned about stack, right? So let me clear the canvas first and let's go here. So in the tree what we have, right? If data we have like 10, right? If we have the data 10 and this node is a root for the tree, right? So we may have some data like 2 we have, right? And the left, this is called left child. And if there is some other value, like if we have 15 here, right? So this is the right child, right? We have two element here uh, for the for this root node. So this is called root node, okay? And this is left child and this is right child, okay? So a tree contains at least two or more than two children, right? But if you are going for the binary tree, the binary tree contains almost two children, right? So what we should have, if there is some data, let's say if we have data like two, we can say fifth value we have here, right? So this have two node have five as a children, right? But rest of we don't have. So this type of insertion, how we will add the root, how we will add a node, and how we will add a children, we will see, right? So this node is known as leaf, right? You can say leaf, right? Leaf. Okay. So if you are okay, then we are going to write the code in here, okay? So let's begin. I'm going to write a class right here. First class should have node. I think we can go right, and this node should contain there should be one data, right? Int data, and data contain integer type data I'm going to add, and it contain uh, node, and the node should be left comma right. We have left and right, and we are going to create one constructor for the node, right? So let it go. Constructor using fields. Here we go. Okay, so we have created a node as a class, and that class we will use in creating a array, right? I think we have already created, right? So we have to change the name while we are working with linked list, right? We have worked on, right? So I'm going to change the name. So uh, you can say tree node. I'm going to give the name tree node, and so I'm going to change the constructor name here, and similarly I'm going to add this name here, and this is the tree node. You can give the name, right? Here we go. I think we are good. So what I have did, each tree node I have two type of data. The first, what we have a data, right? And this data will go to a store here, right? And we don't need these two. We can remove this one, not these things we required, right? I'm not going to add this one, right? Why I'm going to do that? Because if the first node, that is the root, and we don't have any other data, right? Any other, no, that is a leaf. For the leaf we don't have three left and right as pointer, we don't have the data, right? That is a null. So in that case it should be a only one node, right? That should not have the children, right? So I think you are okay, right? So if you doubt here, ping me here, and let's go to the next point. What we have to create here, we have to create a insertion method, right? For the you can say adding a tree node, right? So how we'll do that? There are multiple ways we can create here only. Let me go and create. We can write a public method we can give, or so that we can call it any place, right? So I'm going to, it will not return any data. I'm going to insert a node, right? Insert node, I'm going to give the name, and it will take one data, right? So for each node we have to push a data that will go to a store at the we can say at the position, right? Now what we have to do, we have to do if data is less than equal to the data, right? If if you can say the data that we got now is equal to the data, right? Current data, you can say new data, you can say new data we have, and if new data equal to data, then what we have to do, we have to do some check, right? So is if the first node we have the data, right? If we have the data, so what we have to do, we have to check if the left has data, right? If left equal to null, if left doesn't have the data, what we have to do, we have to put left equal to new and the tree node. We are going to create a node for tree, right? So we can create a tree node here, and we will pass the new data here, right? We can pass here, right? Next, what we have to do, we have to check if done, then else if we don't have, then what we have to do, we have to iterate left dot insert, right? Insert node we have to pass, and then we have to pass the data, right? if data if the data is less than, so sorry, new data is less than the data, right? If data is less than the data, if new data we are going to insert is less than that data, if we have, then it will go to the left, right? So if left is null, we have to create the node, otherwise we will continue the left dot insert, and we will insert the data, right? So now what we have to do, we will check if or then else, right? Else. So in this case, what we have to do, we have to check if 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 we have the data right, if right we have the data equal to, we can say null, right? We have, maybe maybe it have the null data. In that case, what we have to do, we have to create the right node, right? So right equal to new, and then we can pass tree and node we have to pass, and we have created a right node, right? Else what we have to do, else what we have to do, we have to create right insert, right? Right dot insert node, we have the value, right? Okay, we are good. So in this way, we will insert the data in the node, right? How we can store the data in that, right? So let's understand here how we will create the node in that, right? So I'm going to create a node here. You can create here node equal to root, you can say, okay, if you want to create. So what we have to do, we have to create, we have to create root equal okay, I'm going to create a tree for this. I will go to equal to my tree. I'm going to write my tree equal to new, and then we will create an object for the tree, and this will take care dot root equal to, I will check new, and then we will take tree node data it will contain. So we have to take a data. I'm going to take a data as 10, right? Then we will check my tree dot insert. We are not getting why. Okay, sorry. Okay, what we have to do? I'm giving the wrong name here. Okay, we can pass here only 10, and this is the root node. Okay, this is the root node. And if we have the tree, my tree, we have the data here, and we are going to insert tree dot where we want, we have all the ready, we have the data, right? So now we can use data, left, right, or data. We have three things we can use, right? Or either we can insert a new data. Okay, so what we have to do, we have to just insert the data 10. Okay, no, this is not the 10. I'm going to use 5, and then similarly I will copy this one, and I'm going to add here 15. Then I'm going to again here add 8. Okay, so let me check the data, how the data we have in the node, right? So what we can see here, we can just write this out here, and we can print the value my tray dot, we want to check uh, we can say data, right? So let's go and check the data. Okay, see, on the root what we have, the 10 we have, right? So this is the root data. Next we will check my tray dot, what is the left we have, what we have left, and then similarly I'm going to check left dot, first we will check right, what is the right element, right? So what we have in the right, again we are going to pass. Now I'm going to check the left, what we have the left, and what we have in the right I will check. Okay, and what we have in the right. Okay, so one place it will give the error, that should be, I think this place is a error place, so I'm going to keep this value above here, because I know the value should be at the right. Okay, so let it go and run the program. See, we are getting the value, but we are not getting exact data. See, the last element I told you, in the left we don't have the data because it's giving the null value, right? So how we'll check the data? So you have to just call data, then you have to call data, then you have to call data. Okay, here you should not call data. If you call the data, you will get null, right? So here we go. First, what we have in the tray, we have 10. Then we have left as a 5, right we have 15, and then we have in the left what we have here. See, in the left of the right what we have 8 as a value. Okay, so thanks guys for watching this video, right? If you have any doubt, please ping me in the comment box. I will explain you much better, right? So what I did, let me summarize these things. Just I have created a tree node, and I have created a data, and for each tree node that will be a left or right as a children. And if you want to insert a data at the you can say at the first place, right? So it should be like this. Okay, so what we have, this method insert node will check the data, right? Insert node will check the data. How it will check? It will check first if the new data is less than equal to data, right? It means the root node, right? If the root node if the data is less than or equal to data, right, then we will go for the left, right, if this is left, if this is less than, right. So if the left is null, we will create the node on the left. First child we will create as a left, or otherwise we will insert the node at the left. Okay. If right children has data, right, uh, as a null, then we will create the right node, otherwise we will insert the data. So we are good to go, and if you have any doubt, please ping me in the comment box. Okay, thank you.